Vectors classification. Basically, vectors are classified in two categories, that is polar and axial. In axial vector, there is always the reference of angular motion, angular displacement, rotation you might say, whereas all the remaining vectors would be known as polar vector. For example, initially I have shown here displacement, velocity and force. Displacement will give you the information how far the body has gone and in which direction. Velocity simply means the speed along with the direction, and force indicates the strength and direction when it is considered as a vector. You see, vector plus minus vector shall always be a vector. Then in that case, if you take the difference of two vector, you can't write this way because there is one basic binding that sum or difference of two vectors has to be a vector only. So you will put here one vector. This vector would be known as null vector or zero vector. Zero vector is the theoretical necessity in mathematics while dealing with vectors. Otherwise, zero vector itself has no significance. But mathematically, we can't proceed, we can't write this equation unless we use zero vector. Zero vector might be shown this way. Then position vector. Position vector means body is at a particular point, you take the origin, draw one vector from origin to the given position of the body, it will be position vector. R. This would be known as position vector of the point P. Location, if you are having, as for example this one, it is 4 on x and 2 on y, you can say that it is having the coordinate 4 and 2, or in vector form you will write 4i plus 2j. This would be the representation for position vector. Equal vector always means the value should be equal, magnitude should be equal. When you say two vectors are equal, then they must be having same direction and same magnitude as well. When they are opposite or anti-parallel, it simply means they are having the direction value might be any one. When you say anti-parallel, it simply means that they have opposite direction. When you say they are parallel, value can again be different. The only direction has to be similar. You would say both are parallel. When you say the vectors are co-initial, co-initial simply means the starting point shall be 1, might be any number, might be in any direction. If they are having the same starting point, they would be known as co-initial vector. You have one vector A and another vector, they would be anti-parallel. But if you exactly get another vector of same magnitude and opposite direction, you would say that vector B here is negative of vector A. Negative means simply the direction has taken U-turn. This is negative vector. Equal vectors, I told you, position vector. And now what remains to be discussed is only the unit vector. You see, any vector having the magnitude 1 shall be known as unit vector. This is the way. Because when 5 divided by 5, you get 1. And the same thing if it is vector 5 divided by 5, this is vector 1. Binding is here that both shall be in the same direction. So unit vector has value 1, it has direction, but it's not going to have the mod greater than 1 or less than 1. It is binding to be the magnitude equal to 1. These are always noted or denoted by small letters with angular cap over them. Suppose you have a vector in 3D space like 2i plus 3j plus 4k. Then in order to find the magnitude of this vector, you have to simply square all the terms and then add, find the square root. This is 16, 9, 25 and 4, 29. This would be the magnitude of the vector. When you write a vector in terms of I, j and k, you simply give the x component, y component and j component that we are going to discuss at length in following lectures.